to a distance. Resting upon a distant respective x. Is it like that or something?
Yeah, I think so.
So, excuse me. So that's M1, M2. Let P be a general point, a distance A from the same end. Okay. Is it like that or something?
Yeah.
Find an
So,
expression for the total moment of weight used to us about the point P.
so it'd just be mg, like m2g times the distance. I don't know how you would find the distance. P minus y. I don't know if that's right.
Hang on.
Wait, it's a. Would it be a minus y?
Did you say A?
Yeah.
Oh, a distance A from the same end. So this is A. So so we're saying that. So we're taking moments about which point?
P.
This. So moments about P. Yeah, go on. So M2G.
Would the distance be y minus a?
Let's go with that. Okay.
And then the other one is m1g times a.
Okay. And what's the relationship between these two? Or what goes between them?
Add. Wait, no, subtract.
Yeah, so I'll take the first one as being negative and this as being positive. This one will be going clockwise. I just want to think about this though. The total distance from here to here. We could call that distance xy or something. I mean, you're just calling it something, really, aren't you?
Yeah.
Horizontal plank has two particles, M1 and 2, resting upon it, distant respectively x and y from one end, the original point. So move the way 2 to 2 respective point. Okay, and question 2.
I don't really get question 2.
That gives minimum magnitude of that moment. I think that means, I think the minimum magnitude would be 0 because it can't be negative.
Okay. So you want it to be 0, basically.
So I think it's equal to 0 or something. An
Okay.
expression.
And then you have to solve for a, I guess. Like just rearrange for a.
Okay.
So it would be m1ga minus m2gy minus a.
Mm-hmm.
And then you could divide is equal to 0. You could divide by g on both sides just to get rid of it.
Okay.
And then expand the second bracket.
Okay.
M2y plus m2a. So then you could do m1a plus m2a is equal to m2y.
Mm-hmm.
Then factorize out a.
Mm-hmm.
So it would be m1 plus m2.
Yeah.
And then divide by m1 plus m2.
Yep. So that is m2y over m1 plus m2. So we got it in terms of a. This one here, this distance. So we were calling that distance y. Maybe we should call it xy, like capital X, capital Y. That seems like it's just a name. I just want to see what they said here. So they reversed it. Was this? So they didn't put it in the middle. Yeah, because it wasn't really obvious. So the total moment is m1g. I mean, it's written a bit different, but there's really they really didn't specify that it shouldn't be between them, I suppose. Then this one is over m1 plus m2. It's got m2y, but it also has m1x. Why is that? So they just made their first one equal to 0. There's a problem with that though. So they said it was equal to 0. As a is x plus that, or as y plus that. So a is between x and y, so the point P lies between the two masses. The minimum possible value of a magnitude of a moment is 0. Yeah. So hang on. M1. So find the expression for it is, I think it's just in the, hang on. And A. So they should have specified in part A that like it's, like assume it isn't between them. So what we recognized was the magnitude would be 0, and then it said show that it must be between the 2 points, and so that's what we did. We just assumed it, I suppose. Okay, so what they did was they assumed it's not between the 2 points.
Mhm.
Let's just do, let's now assume it's not between the 2 points. So
Okay.
do that. So it was x, y, and p, m1, m2.
So it would be m1 times x minus p. But x minus a.
Hang on. Let's get this right. So it was a was the total distance. Is that it?
Yeah. Wait, wouldn't it be a minus x then, the distance?
The distance of what to what? So p is the center of rotation, is it? Or taking moments about p. So taking moments about p. What is the distance from x to p?
A?
Yeah, but okay, so we're actually going to consider x isn't at the end.
Mm-hmm.
Okay. And so,
A minus x.
Yeah, this is crap. So a minus x times.
M1G.
Yeah, hang on, let me just check. Yeah. See, this is crap. X isn't. X is a distance now. You know, they're saying x is a distance. Uh, this doesn't make any sense. Resting upon it distant. That doesn't. Okay, so that's just a. That's not coherent English. Doesn't make any sense. So what they meant was that this distance here is x, and this distance here is y. All right, so it's just very, it's not correct English. So find an expression. So I'll just do it again. So from the point P, yeah, it is a minus x times by m1g. Okay, and then the other one?
Plus, wait, no, minus M2. Wait, if it wasn't in between, then they would be in the same direction, right?
Uh-huh.
So it would be plus M2G times A minus Y.
Yeah. So that is our expression for the total moment of weight due to the two masses. We could make it. So that one says x minus a, y minus a, but we have. So a is the distance. Is that just because it's on the left? A distance a from the same end. Yeah. Hang on. So if we put P here, which they didn't specify, then it would be the other way around. I'm happy they really didn't specify. Okay, and then part 2 will be
Equal to 0.
Yeah, make it equal to 0, and it's the same as what we did. I think you'll be. Yeah, I'll be fine. So.
How do you do the other part of 2? Show that the point is always between the resting points of the two masses.
Okay. Hang on. So go on then. Make it equal to 0.
Okay. Expand it first. So M1GA minus M1GX.
And actually, hang on. At this point, I can divide everything by G.
Oh, yeah, okay.
Instead of doing it later. So that's M1A
minus M1X plus M2A minus M2Y is equal to 0. So then that would be M1A plus M2A is equal to M1X plus M2Y. And then just factorize out A and then divide by M1 plus M2.
Yeah. So let's just say it. That over M1 plus M2. We're factorizing out A. Okay. We have to show that it must be between that. They said you could split this up as x plus something, x plus the y part, or y plus the x part, if I remember correctly, when it's equal to 0. m1x, m2y. So we have the same exact thing. So this can be written as x plus m2 being factorized out.
How would you factorize m2 out?
They wrote x separately.
I did not know you could do that.
So I just want to see if they did this through a very long type of. Hopefully, it's not like rational expressions, like partial fractions, I should say. So they could write this as m1x.
I don't think it's partial fraction because doesn't partial fractions have to be multiplied like the denominator?
So that's what I'm hoping. Let's say m2y, m1 plus m2. So that's if we were to split this up.
Mm-hmm.
Let me see. I don't see how that would work. They're saying it's m2y minus x as x plus. They're saying it's just x. I just want to see if it's something to do with their diagram. A is this distance. A is equal to the distance x plus that. A is the distance x. M2y minus m1, sorry, minus m2x. So they're saying a different way of writing this expression is this expression.
Mm-hmm.
And they're also saying that like these are two different ways of writing that expression. Just wondering, where did that come from?
I don't know.
So if you were to have it separate as x, if we were to separate out just x purely by itself, how would you get x? X, the only way I can think is if it was x so as a fraction that would be x over 1. Yeah. Just keep that. But they have y minus x. If you were to expand that, you would get m2y minus m2x. And so they have x separately. So m1 plus m2 over m1 plus m2. m1x. Okay, I think I see. For some reason. So they had on top m1x plus m2y.
Mm-hmm.
I think they did an additional m1 x minus m1x. So they could literally bring out x.
Okay.
That's the correct answer. Okay, that's the correct response. So x plus something and y plus something. So a is the distance x plus something. A is also the distance y plus something. If y is greater than x, the first expression shows that a is greater than x. And the second expression shows that x take away y is less than 0. Similarly, if y is less than x, the first expression. I say we don't bother with this. So
It literally says A is less than Y, and then it says A is greater than Y like 2 lines later, so I don't really know.
So they're just messing around. Like they're just going with their assumptions. So if you were to draw this diagram with x being greater than y, then x would be greater than y. If you drew it as x is less than y, then x would be less than y. It's like, sure, that's true. But they're saying that a must be between x and y. I mean, okay, but you didn't draw it as a being between x and y.
Yeah. Did
The,
confusing.
I lost it there, but I saw a second like misprint type of thing in the same way that the question was badly corrected. No, it's true. It should be between them, but x plus something gives you a. That's not true. And y plus something gives you a. That's also not true.
I mean, if the fraction was negative, it would be true, but I don't know how you would go about doing that.
Nah, let's not mess around with it. It's not a great question, to be honest. Like they worded it wrong right from the start. I'm not worried about that. Any questions about it?
No, it's just like weird.
Yeah, they should have worded it correctly from the start. They're not quite. I can see what their thinking is. If you make one assumption, then it's this way. If you make another assumption, it's that way. But they should have been more clear. Okay, let's try this one.
Okay. So, okay, so then there's 60G at P going down. And then there's 90G in between H and K. And then there's also 20G from the Planck going down.
Okay, and I don't know if is it exactly the
It
same symbol.
says AH is 1 meter and BK is 1 meter. So the middle bit is 4 meters.
Okay.
I don't know where the mass is going. It's probably from the center. Yeah.
Yeah, uniform.
And then you have like reaction forces from the supports. So I guess you could take moments about one of them to find.
Pick
Yeah.
one.
The H, I think it's easier, but so that would be 90G times 2.
Yeah.
Plus 20G times 2.
Mm-hmm.
Plus 60G times 5. is equal to, what's it equal to? Is it equal to RH?
I believe RK. We're taking moments about H.
Oh yeah, so the force doesn't count. No, wouldn't you have to do, yeah, wouldn't you have to do minus RK times 4? Yeah, or you could just put it on the other side. Yeah. So then you have 180G plus 40G plus 300G is equal to 4RK. So then you get 520. So RK is equal to 130G. And then you do the same thing, but you take moments about K.
You now, like with simultaneous equations, you now have one answer, so the second is a much easier way to get it.
How?
What must...
Wait, yeah, it's going to be 90 plus 20 plus 60.
Yeah.
Oh, yeah. RH is 40G.
So this one is 40.
Yeah. Is it possible? I'm going to go no, it would tip over.
I don't know. Quentin, sorry.
Yeah, that one. There.
Sorry, I wrote K, it should be Q's. What is it? Is it possible for Quentin to move slowly towards and reach threshold K? While the plank remains horizontal.
And maybe it is possible, but...
So if Q was to move on top of K, would it remain horizontal?
No.
What do you think?
I think no, I think it would tip over.
Why is that?
Because most of the weight is on K, and there's probably barely any weight on H. So I don't know if it would work.
I think it is possible if he was to move exactly there. So the weight is on K, but some weight is still on H because of this 20G.
Oh yeah.
And so because anything is still there.
Okay.
I mean, we could calculate it. Did it say how it is worth any marks, or was it?
It doesn't show marks.
We could calculate it. Or can we?
How?
So we could.
If he's on K, and then take moments.
Yeah.
Okay.
Okay, let's see what happens there.
So you would take moments about H, right?
Either one, I believe.
Then you may as well do K because everything is on there. So the only force would be the only moment, would be 90G times 1, I suppose.
No. What's the distance from Quentin to K?
Oh, sorry, I meant 60G times 1.
Sorry, yeah. Okay.
Yeah, there's a person at the end.
Are we going or not going?
And then 20G in the middle times 3, no wait, times 2 plus RH oh wait, no, minus RH, sorry.
Okay.
Times 4, which, yeah, okay. And it should be 60g times 1 plus 20g times 2.
So 60g is that way. I'd say that would be minus, wouldn't it? Like I'd take clockwise to be negative.
Oh yeah, that would be.
So that's going to be negative. And we have the 20g. That's going to be positive.
That means the reaction at H is also going to be positive, I think.
I take clockwise to be negative.
Oh, that's clockwise. Never mind. Okay. So minus 60 plus 40 is equal to RH times 4. Minus 60g plus 4.
Okay. Hang on. We're kind of assuming it's equal. Maybe this is a folly. Maybe this whole thing is a folly. 4RH. Yeah. So that's minus 60g plus 40g.
It's going to be negative.
So that's going to be negative 20g is equal to 4RH. So the reaction at H is
Minus 5g.
aha. Therefore,
The plank can't remain horizontal.
therefore it won't. So not horizontal. I think we kind of assumed. Yeah, so we kind of assumed equilibrium. But other than that, if it's negative, yeah, then it would be lifting.
Why would it not be in equilibrium? Oh, if it's not horizontal, it wouldn't be in equilibrium, right?
No. I think that's the assumption to make. Maybe like assuming that it's in equilibrium, we get a negative, so therefore it can't be. Yeah, so then it can't. Yeah.
Okay.
Okay.
Now
Number 3. I'll just go back to there. Okay.
I don't know how to do part 3.
So that is the midpoint of the plank. You'll be all right. Paula again stands at NB. Determine the region. Okay. Let's make some room. So we can just redraw it.
Mm-hmm.
So
It's at the midpoint, so it's at 3 meters.
So that's H.
And then Paul is still at NB, so that would be 60G at B.
60G.
And then you'd have the 20G of the plank at H. And the reaction forces as well.
And what about the Quentin?
You have to figure out where he can stand so that the plank will be horizontal. So how do you do that?
Hang on. At the moment when it's about to turn, the reaction at that point is 0.
Yeah.
Okay, let's see. Now the trestle H has moved. The midpoint is there, Paula. So we say where Quentin can sense the plank will remain horizontal. So we have a weight here. So if Quentin was, I think, anywhere like in between, it would be fine, wouldn't it?
Yeah.
Perhaps if he was here, it wouldn't be. It would tip.
Yeah, because that would be too much weight on.
Yes. So we need to. So somewhere here.
Would that be? Yeah, that would be okay. I think.
What? Quentin is 90.
Mm-hmm.
But what if? So if you put like 90 there.
That would tip.
That is 60. So you just have to kind of determine the region.
Okay.
where this would begin to lift off, where k would be greater than 0, I believe.
Okay.
Or,
But if it's
or,
greater
or
than 0, wouldn't it?
so
Yeah.
let's say less than 0, we'll say.
Okay. Wait,
Yes.
less than 0.
Yeah, so we want the reaction at k to be less than or equal to 0, I think.
Okay. So would you take moments about k then? How would you solve that inequality?
Yeah, take moments about k.
Okay, so 60g times 1, or minus 60g.
Yeah.
And then 20g times 2. I'm not sure about the direction.
If we're taking moments about k and the arrow is going up that way, it kind of
Oh, one
spins.
going down, but okay. But it's someone going down 20g.
Oh, and so what will that be?
Okay, so plus,
Yeah,
and then minus RH times 2,
I'll try 2 with h.
which is less than or equal to 0.
We have Quentin as well.
Oh yeah, but you don't know where like the distance is.
And so you'd have to give the distance a name or do something with it.
X, I guess.
Okay, so what would you say then?
90gx.
I'll call it D for distance.
Okay.
Okay, and is that plus or minus?
It's a plus.
So this is moments about k.
Yeah.
Let's see, the reaction at k. Did we do the reaction at k? No, we're taking moments about k.
Okay. But wouldn't it also be? Can you also do like RH is less than or equal to 0? Like, doesn't matter which one you do.
I believe so. We think that the only place Quentin could stand to tip things over would be on this side.
Okay. Oh yeah. Okay. Then it wouldn't be RHs.
Yeah, it would increase. Hang on. So are we saying that this whole thing would this whole thing be less than or equal to 0?
I don't know.
Where's that? So the reaction at k. So we kind of eliminated the reaction at k, didn't we?
Yeah. I think that was meant to happen.
Was it? Okay. Go on. What is this?
What is what?
What do we do with all this stuff then?
Uh,
Minus 60g.
plus 40g minus 2RH.
Okay.
So it's minus 20g plus 90gd minus 2RH.
Da, da, da. So we need reaction k to be less than or equal to 0. I think we shouldn't have eliminated the reaction at
Yeah.
k. Yeah. So what do we do?
So take moments about H. So 60g times 3.
Okay. So it's 180g. And is that plus or minus?
Minus. And then minus RK times 2.
I believe that will be plus.
Wouldn't it be clockwise?
So we're now taking moments about h.
Okay, yeah. It would be anti-clockwise. And then 90g times d. That would be negative.
We're taking moments about h. That's going down.
Oh, positive. Is, yeah, that's it. And then you could do, or you have to equate it less than or equal to 0. Or would you have to get RK on itself, like by itself first?
But how do you? Pause the region that we're quantum constants. I'm missing something. Similar, I think it's kind of similar to the previous question. That they would say it's bigger than something less than something else. So we have it as an expression, but we want it as an equation in some way. So previous one, RH was,
Yeah, we got that, I think.
I think we did, yeah. 130 and 40. That was, yeah, 130 and 40. Taking moments, it is not possible as the reaction force cannot be negative, so we got that, minus 5g. Taking moments about h. What is this? 60g times 3, and that minus d. So that's what they did with this distance.
Mm-hmm.
3 minus 6, they said it's equal to 0. Okay, they said it's equal to 0. So it's equal to 0. So, okay, what do we do here?
I guess you could divide through by 2.
Yeah, that's
Just
not bad.
to make things easier. Oh, it's 90g.
Oops.
And then RK plus 45GD is equal to 90g.
Okay.
Or you could just do 90g minus 45GD. And then you want that to be less than or equal to 0.
So, yeah, so that
If
was,
you want the plank to remain horizontal, then wouldn't you want it to be RK is greater than 0?
yes, correct. That would be greater than 0. So you want a reaction, yes, you want it to be like a positive reaction.
Yeah. And then factorize out G. Or like divide through by G, not like factorize.
Yeah, not worried about that just yet. Okay.
I get, yeah, I don't, I guess you could 90G is greater than 45GD.
Okay. 90 is greater than 45D. The important bit is the D.
So 2 is greater than D.
The important bit is the D. This distance,
Mm-hmm.
what is the distance from A to the center? Is that 3?
Yeah, it's the midpoint.
So this is 3. And so what would be this distance D? Okay.
Less than 2.
I believe we could refer to it as like 3 minus D or something, or 3 minus X.
Yeah, 3 minus D.
Okay, 3 minus D. And so You could say, what could you say about
D is less than 1. Yeah. Wait, no, D is greater than 1. So.
D is greater than 1? That's on this one. Same thing for the other one. You make it equal to 0.
How would you do the other one?
Or
Because you
maybe,
don't have RK.
oh, hang on. So if, hang on, no, you're right. So D is greater than 1, but it can't be much greater than 1, like forever.
Yeah.
What is D less than?
6.
And can we go even less?
5? I don't know.
Like, could it be like 4 or something?
Yeah. It could be, I think.
Yeah, actually. So D is just between 1 and 6.
Okay.
Is that right? Because that would give a positive reaction. The region of the plank where Quentin can stand so the plank may remain horizontal. Yeah, I think between 1 and 6, but not between 0 and...
Okay.
He must stand at least 4 and 7/9 from end A. Hang on. It has to be greater than 1. So they took moments about the other one, and they made it equal to 0.
Oh, that one also has to be greater than 0, apparently. As in, you do the same thing on the other side.
Doesn't tip. But hang on. If this distance... Oh, okay, so it is possible for it to tip if it's down there, is that right?
I
Yeah.
think, yeah.
Okay, so that one is equal to 0. So same thing for that one.
So you want RH is greater than 0 as the inequality.
Yeah.
So then you have minus 20G plus 90GD is equal to 2RH.
Okay. Fine. You don't do it for me.
And then that would be minus 10G plus 45GD is equal to RH. So then you could just make the whole thing greater than 0.
Let's see. So 10,
45.
45, RH.
So
So
45GD minus 10G is greater than 0.
greater than 0.
So that's just 45D is greater than 10. And then D is 10 divided by 45, which is 2/9. That does not look right.
It's because, so what D are we referring to though? So we're using the same letter, but it's a very different distance now.
Oh, it's from B, I think. Yeah.
Yeah.
So 6 minus 2/9 is 52/9.
Is 52
Sorry,
over 9, which I think is 4 and 7/9.
479. No. 36 plus, it's 43/9 for 7/9. All right.
9. Let's take a look. I'm kind of seeing a problem from this. For
It's
R,
because you have to do like 5 minus x or something.
okay,
We did like a different variable. Like it's a different distance. So
yeah, they did 5 minus x. Is that because they're not counting this thing down here? This A part?
I think it's they're not counting the bit between K and B because they're taking. Oh wait, no, they must be counting that. Sorry, I
I
don't know
think I think
why
they're
they.
not counting the bit from A. I think they're not
Yeah, they're
counting
not
A.
counting that
So they did 5 minus instead of 6 minus.
because yeah, because we already know X is greater than 1. I think that's why they did that.
Oh, okay. Okay. So he must stand at least 4 7/9 from end A.
Yeah,
Okay, alright. Fair enough.
I get it though.
Yeah. Any questions about that?
No,
Alright. I keep thinking of where he shouldn't stand, but their thing is where he should stand. We'll
that's
see. We'll
question.
see. Okay, question 3. Looks like it's even harder. Okay, let's try this.
Okay. Mm, well, it tells you the weight and uniform. So you know that 1 meter there's 40 G, like the weight of the plank. I don't think that would be the weight of any, like there would be any other forces. Oh wait, no, there's the fence putting a reaction force, I think. I don't get the bit about the rail. What does that mean?
I don't really understand either, to be honest. Hang on. So the diagram shows a uniform plank which rests horizontally. So this is the plank
I think so, yeah.
on a garden fence. So this is the fence. And maintains contact under a horizontal rail. So there's like a second or something.
I know, I think the plank is under it, so the rail is like above
Okay.
the plank. Weird thing.
Hang on. And it has contact under a horizontal rail. Coefficient of friction between the plank and the top of the fence is mu1, and between the plank and the rail is mu2. The plank is of length 2 meters. It projects 20 centimeters beyond the rail, and a
So the
distance
rail is only like 1.8 meters, and there's 30 centimeters between, apparently, between the
so the
rail and
fence
fence.
and the rail. Hang on. Does that mean that that's 30 centimeters?
No, I think it's like a vertical distance between the. It's not exactly clear, but I think that's what it means. Like between the top of the fence and the rail, so it's like vertical, yeah, like that.
So like that's 20.
Wait, why does that have to be? Oh no, no, I think that's 30. I think you know what it says 20 centimeters beyond the rail. I think it's just like longer. Plank is just longer than the rail. I think that's what that means,
Oh, okay.
but I'm not entirely sure.
Like,
It's not the clearest question.
why would they not be on their diagram? Okay, hang on. The plank is of length 2 meters. It projects 20 centimeters beyond. It projects 20 centimeters beyond the rail. So the rail is shorter. It
Yeah,
doesn't say
like
on which side though.
yeah, it doesn't say.
And the distance between the fence and the rail is 30. So going, does that mean vertically?
I think so.
I mean, I assume there's no distance between the fence and the plank
Yeah, yeah.
vertically. And so why wouldn't they just say between the plank and the rail? Oh no. The weight of the plank is 40 newtons. All right. Let's just. Who knows?
Find the horizontal force sufficient to move the plank to the left. How do you find that?
The horizontal force that is just sufficient. So F equals mu r.
Oh, it's like, yeah, when it's on the point of tipping, that one.
Yeah.
So the mu between the plank and the fence is mu1. So that's the one you would need. Would
Okay.
you need both? I don't know.
So that's. You might need both.
And then calculate reaction force, which is, I'm guessing that the reaction force is just 40G because it doesn't look like there's any other forces acting on the plank.
But would it be like 40 g times this
No, but
distance?
it's a force. So,
Yeah, you're right actually. Okay, so that's just the reaction force is just 40 g.
so F is equal to mu times 40G. So then wouldn't that be the horizontal force that is sufficient in,
The horizontal force, but there are two things to take into account here, are there? Like mu1 and mu2.
wouldn't, I don't know what mu2 would be. Like, what would the R be for mu2? Is there a reaction force between the plank and the rail?
You would assume there must be.
But what is it? How do you find it?
I mean, they don't specify that the rail has any weight or anything,
Yeah, it just says
or,
horizontal.
or any mass, and
Mm.
it doesn't refer to it as light.
Yeah, it doesn't say light.
Okay, question two, I suppose.
Wait, is that the answer? Okay.
I mean,
Is the force just sufficient to continue to move it increase or decrease? What? I don't even get that.
is the force just sufficient to continue to move it?
If
Okay.
it's moving, wouldn't the friction increase? So the force would also increase. The force you need to move it would be increased, wouldn't it?
I mean, up to F max.
Oh yeah. But that is F max already if it's F equals mu r. I'm very confused.
So, okay. I think, is it also like F equals ma? And so,
Oh yeah.
once the plank begins to move, I suppose you have some like momentum or something. Is that what you're talking about?
Yeah, that's
Is
what I thought it would be like the force would increase.
and so, go on. What are you thinking?
I think the force that is just sufficient to continue to move it would be increased because you would have an acceleration.
All right. I'm gonna
One.
guess. I'm gonna guess decreased. Just I'm
But
just
also
gonna.
it's moving on a horizontal surface, so why would there be an acceleration when it just be on constant speed if you're pushing it?
That's what I'm thinking. I'm thinking once it gets moving, I think it's more to do with momentum. Is,
Okay.
is the force just sufficient to continue? And just kind of in real life, if you're pushing a
Yeah.
plank along a table, kind of it takes more force to get it going, but then you
Yeah,
can just kind of,
that's true.
oh, why?
These
Okay.
questions are so weird.
What?
Okay, I don't know
Taking moments?
about the fence. Like
Hang on. See, it would have been lovely for them to give us
they just draw the most random diagrams. Like
this information. Oh, okay. No, I did. To be fair, I did forget about this little circle over here.
I don't know what that circle is. What is it?
I don't know.
Is that meant to be the rail?
I mean, they didn't mention
It never says anything about weight on the plank. So Maybe that's what do the rail. I don't know.
So, hang on a second. Oh, so the plank is 40 newtons. So fair enough. So that's not 40 G. That's just 40.
Oh yeah. Okay. They did some moment stuff.
But that's no. They like what is this thing?
Right.
Why? What? Where are you getting these? Like, is your teacher giving you these questions or something?
It's like online. Like it's a website. They have literally like every topic and they have questions for every topic.
Like I've seen them
And like
troll.
teaching stuff for every topic.
Okay, so again, it's just a very, very poorly worded question. Like, they're saying that this is meters, so this is 1 meter, and then this other side is 1 meter.
Yeah.
But
The
they are
plank
now saying
is
that
2 meters.
they're 20. So this is the rail. This circle is the rail.
I think so. But also they have like 4 reaction forces. And no, there's like two.
So this 20 centimeters that they're referring to. So that was my guess that that's 0.2.
Yeah, I think that ball is meant to be the rail because it in the diagram that like you copied, it's like 0.2 past the round ball thing. But it says horizontal rails. I'm really confused.
Yeah, like that's
I
not a
don't even know
rail.
what that is, but
So, so, so many questions. So that's 0.3.
and the 30 centimeters between the fence and the rail is not shown on that diagram properly.
Like,
Oh, it's
well,
meant to be like the distance between the ball and the fence because that is the rail, apparently.
yeah. So this is called a rail.
Why?
I mean, just call it a ball or something. But okay.
Like
Um.
something, yeah. This is
So
so confusing question.
they took
Here's basically
moments.
what we did, but without the weird diagram.
If the plank has moved the distance. I mean, this is
Yay,
just.
the force required decreases. It's basically common sense. But
Yeah. They like this would have been much easier if they just. Yeah.
they should just give the diagram if they're going to be confusing.
Yeah. It's the way they're wording those questions. Anyway. All right. Yeah. How was that for you, Amogha?
Good, I get moments, but those questions are just weird.
Yeah. Uh, anything in particular you want to do next time?
I'll just send questions again.
All right.
I'll
Uh,
try and make sure they're not confusing. I didn't read through these before I sent them, but I
uh,
probably should have.
I should have as well. I just forgot because I marked your email as read and I just forgot. I planned it
It's
differently.
fine.
Any questions for me in general?
No,
All right. Well done, Amogha. You did great. I look forward to you talking again next week.
thank you. Bye.
Have a good week. Goodbye.